Hey there! Today we're going to talk about scientific notation. Scientific notation is all about moving the decimal over, let's say 1, 2, 3 spots, to rewrite the number, let's say as a 2.3 versus the original. Scientific notation is a way to express numbers that are very large or very small, and it uses powers of 10 to do so. Let's say we divide all these numbers by 10, just to see which way the decimal goes. So when I divide 1,000 by 10, it moves it over one place to the left, and I get 100. I divide 100 by 10, and I get 10. I divide 10 by 10, decimal moves one place left, I get 1. And if I divide 1 by 10, decimal moves one place left, I get 1/10. Notice the pattern of the exponents which decrease from 3, 2, 1 to 0, and then -1, -2, and then -3, as we continue to divide by 10. Please note that when the exponents become negative, these represent fractions, such as 1/10, 1/100th, or 1/1000th. It is important to keep in mind when you see a negative exponent, it means this is going to be a number smaller than 1, which means it's a fraction. When you multiply by 10, you'll find the decimal will move one place to the right, so that 1 times 10 will become 10. 10 times 10, move the decimal one place right, becomes 100, and so on. So movement of the decimal to the left or to the right is what scientific notation is all about. Scientific notation looks like this or this. It always has the decimal right behind the first number. And it always has a times 10 to the power of something or other, with the negative power meaning that it's a fraction, and the positive power meaning it's a number greater than 1 or equal to 1. Next, we will write numbers from scientific notation into standard form, which is a basic regular decimal number. Let's use 9.326 times 10 to the, we'll call it -4. We are going to use the negative sign as the pointer. It'll point us in the way to go with the decimal. So to write this number in regular form or standard form, we're going to move the decimal in this direction 4 spaces. So if you look at the exponent, it tells you how far to go, and if it's a negative sign, it tells you which direction to go also. Using the same example, we will move the decimal 4 spaces to the left, 2, 3, 4, and add 3 zeros. So this would be our final answer. Here is one more. In this one, we're going to move the decimal 6 spots backward to the left. Why? Because our arrow and our negative sign tells us to. And here is the resulting answer. Turn off the video and try this one. It all begins by recognizing that that negative sign is actually a left-hand turn signal to go 3 spaces to the left. And the answer should be 0.0102. I will provide answers for the rest of these. You should try them. So here they are, and you should recognize that these numbers all have negative exponents because they're less than 1, which means they're a fraction. Now with bigger numbers, they will have positive exponents, and there will be no negative sign, or as I call it, a left-hand turn signal. So on these numbers, if you don't go to the left because there's no left-hand turn signal, which way do you go? I hope you said to the right. And this is our answer. This one says move the decimal 2 spots to the right. And this is our answer, 139.9. This one says move the decimal 4 places to the right, and the answer is 140,000. Stop the video and try the rest. I'll give you the answers. So here they are. To summarize, this is taking a scientific notation type number and turning it into a regular standard number. And remember, one has a left-hand turn signal, which is a negative sign, and the other does not. So you go right. Now we will do the opposite. We will take a regular number in standard form and write it in scientific notation. To do this, you have to recall that the decimal has to be moved right behind the very first number, And to find the exponent, we will count the number of spaces that we have moved. We will use a negative sign for small numbers less than 1. Let me explain. As you recall, fractions or small numbers have a negative exponent. So to begin this task, we have to move the exponent right behind the first number. If we start here, we will move 1, 2, 3 times to do so. That 3 is how we find the exponent number. We write this number as 8.092 times 10 to the negative 3 because we have recognized that this number was smaller than 1 or a fraction. Therefore, we have to give it a negative exponent. Looking at this example, we see that this is a number less than 1, so it's going to have a negative exponent when we finish. We're going to move the decimal right behind the first number, which is behind the 3. It has to move 2 spots. So the answer will have to be 3.56 times 10 to the negative 2. In this example, we need to move the decimal right behind the first number, which is the 7, which means we have to move it 3 times, ending up with 7.09 times 10 to the negative 3. I will do the rest for you. And here they are. Hope it worked for you. The key here is recognizing that little numbers are going to have a negative exponent, and that big numbers larger than 1 or equal to 1 are going to have a positive exponent. But the basics remain the same. We have to move the decimal right behind the first number. It's going to move 6 times, so the answer for exponent 6 is true. And the number writes out as 4.89 times 10 to the 6th. I will do this one for you and let you do the rest. The decimal will be moved right behind the first number. The decimal is moved 10 spaces, so the exponent will be 10. And the answer will be 2.3 times 10 to the positive 10 because this is a number larger than 1. Here are the rest. So here they are. I need to remind you to drop all the zeros to get the final answer, as I have done so here.